This is a very common problem you encounter when you want to make solutions. I encounter this problem all the time in lab. I have to figure out how much of a chemical I need to dissolve in order to make a certain volume of a certain concentration. So to go through this, we look at the formula. We can use 3.5 molar as a conversion rate. In other words, 3.5 molar is just another way of saying that 3.5 moles, there are 3.5 moles for every liter. So essentially that is an exchange rate, a conversion. And we have 2.0 liters of solution that we want. So we can do a fence post. We say every 1 liter requires 3.5 moles. So if I want 2 liters of the solution, I am going to require 7 moles of NaNO3. And I want to know how many grams of NaNO3 I need. So I'm doing this as a separate fence post, but really we could have done it all in one. So 7 moles of NaNO3, well 1 mole of NaNO3. I will simply now add up the molar mass of NaNO3, which will be 85 grams. So 7 moles will be times 85. I will need 595 grams of NaNO3 in order to make this solution. And when I make this solution, one thing to be clear on is I always add the solid first. So I take a 2-liter volumetric flask, so this is the 2-liter mark. I put all my salt in first, and then I add my water, because I'm actually not going to need 2 liters of water. I'm only going to need enough first to dissolve it, and then I'm going to fill it to the line. So I'm actually probably going to need a little less than 2 liters to make this work. But ultimately, I'll have 2 liters total, and that's how we describe molarity solution.